Welcome to Maths and Science by IITian. In this lecture, I will be taking up linear algebra, most important topic for finding the solutions of simultaneous equations. For that, we will be using the method called as rank of a matrix. From the rank of a matrix, we can solve the linear algebra question of finding the behavior of simultaneous equations given in the examination. The simultaneous equation solutions and its behavior is one of the major topics in JEE Mains and JEE Advanced. This rank, once we know the basics of finding the rank of a matrix, then we can solve this problem in linear algebra of finding the behavior of the simultaneous equations. Simultaneous equations, it's very important. It has got lot of engineering and science applications. The behavior of the simultaneous equations, whether for the given simultaneous equations there is a solution, a unique solution, or there is no solution, or there are infinite solutions. That means the equations are inconsistent if there is no solution. They are consistent and also have a unique solution, and the equations can be consistent but have infinite solutions. That means we will be dealing with consistency of simultaneous equations and inconsistency and unique solution, infinite solutions, and no solution. These are the topics which we will be discussing in this lecture. It's a very important lecture. Please listen to each and every aspect carefully. Please view it, and while viewing the lecture, please make a notes of it also. These are all the aspects very important. They will be useful even for your future engineering courses. Whether it is electronics engineering, whether it is computer science engineering, whether it is data analysis engineering, these are all the things very important for you. Now, let us take one 3x3 matrix. Question: find the behavior of a given 3x3 matrix. This we can do in seconds. Whatever I am explaining, this may take a little bit, about some 20-25 minutes for explaining the procedure. If you do it perfectly in the procedure, the answer can be obtained in less than a minute. The first and foremost thing what we have to find here is, write the 3x3 matrix, perform elementary, which I have explained in the previous lectures. Please see that. Elementary row and column operations to see whether any row or column becomes 0 for all elements in that row or column. If a row or a column becomes 0 means what it means? It means, please try to understand, everything was explained in the previous lectures. It means determinant of A is equal to 0. That means determinant of A is equal to 0. If determinant of a 3 by 3 matrix is 0, then we have to go for the 2 by 2 matrix. Next step, reduce the given matrix to the matrix having non-zero columns or rows. Non-zero means completely zero. Completely zero. Completely non-zero. A single element being zero, it doesn't matter. Completely non-zero. This is the most important step. This I will explain you. For example, A11, A12, A13, A21, A22, A23, A31, A32, A33 is a matrix A, and after elementary and row operations this matrix is reduced matrix A dash is equal to A11, A12, A13, not A13, A dash we can say, 0, A22, A23, A dash 31, 0, nice, sorry, let us make one row 0. This is a 3 by 3 matrix, original matrix. A dash is also 3 by 3 matrix, but it has one row, total elements 0. Because total elements in a row or a column are 0, what is the determinant? Element into cofactor, element into cofactor, element into cofactor. That is the addition of all those. What is the determinant? Determinant is equal to, in the last class I have explained you, A11, A11. This is the cofactor, this is the element. A12, A12 plus A13 or A13, or it can be determinant can be A31, A31 plus A32, A32 plus A33, A33. In the new matrix for A dash, this is for A. For A dash, new matrix, determinant A dash is equal to A dash, that is equal to determinant A dash is equal to A dash 31 into A31 plus A dash 32 into A dash 32 plus A dash small a dash 33 into capital A dash 33. These are all cofactors which I have explained in the previous lectures. Please refer to them. When dealing with the A inverse in the last class, I have explained how what are the cofactors. And this is the element. Now, what will be its value? Determinant of A dash is equal to, what is A dash 31 in the new matrix? 0. 0 into capital A dash 31 plus 0 into capital A dash 32 plus 0 into capital A dash 33, that is equal to 0. That means my determinant is 0. It's a singular matrix. When singular matrix and determinant is 0, then the rank is reduced. The rank is non-zero elements, non-zero rows and columns, after completing all the possible rows and column elementary operations. This is the result. Then this becomes A double dash is equal to A dash 1 2, A dash 1 3, A dash 2 2, A dash 2 3. Just for visualization. And what are the number of non-zero elements and non-zero rows here? Only these two. That means rank of the matrix is equal to when the rank of the matrix, this is the rank of the matrix A dash. Now, second thing, how this rank of a matrix is related to simultaneous equations. Now we got the procedure how to get the rank of the matrix for the simultaneous equations for a 3 by 3 matrix. Now, how this rank of a matrix is going to help in finding the behavior of the simultaneous equations. Now, let us say A11 x1 plus A12 x2 plus A13 x3. x11, let us say x12 x13. This is the form of the equation, simultaneous equation, is equal to something, some value b. That means, for example, you can call it as x1, x2, x3, or you can call it as x, y, z. There is no problem. This is a variable. This is a x is a variable. This is a variable. This is a variable. This, if you want, I can write even like this. A11x plus A12y plus A13z is equal to some b1. It's a constant. X, y, z are variables. And second equation is A21x plus A22y plus A23z is equal to b2. A31x plus A32y plus A33z is equal to b3. This is the set of the simultaneous equations usually being given in the examination. The a values, the constant values may change. The constant values may change. Now, in this, the value of a11, a12, a13, these are all coefficients of x, y, z. X, y, z are variables. X, y, z are variables. Please try to understand me. a11, a12, a13 and so on are coefficients of respective variables. Understood? Now, next is b1, b2, b3 are constants. Are results of the equation. Equation 1, equation 2. That means some equation a11x plus a12y plus a13z, that is equal to some constant. That is the result of the equation. 3 equations are there, 3 variables are there, 9 coefficients are there, 3 result constants are there. Now, how can you write in the matrix form? This particular matrix, with this particular simultaneous equations, how to write in the matrix form? That is the crux of the problem here. To write in matrix form simultaneous equations. This lecture is taking little bit long, but however it's worth. This is a11, this is a12, this is a13, a21, a22, a23, a31, a32, a33 multiplied by x, y, z. You know the multiplication of what you call matrices, that I have already explained, is equal to constants. That is b1, b2, b3. Do you agree? When you multiply a11, a12, a13, this is a whole matrix A. This is matrix X. This is variable matrix. This is constant matrix B. Let us say AX is equal to B. X can be found out when A has a inverse. It means X, that means x, y, z. We are interested in finding x, y, z. X, matrix X can be found when A has an inverse. In the given form, AX is equal to B. It will have a solution. It will have a solution when A has an inverse or A is invertible or determinant of A should not be equal to 0. Now, we have written AXB. Now we will be operating whatever elementary and row operations on, we will keep X as it is. Second step is, this is not the first step, it is only observation. It's only observation. Okay. Now, the step 1, what we have to do, it is only observation. This is step 1. What is step 1? Write the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 in the matrix form. Given simultaneous equations, let us write like this, that is equal to B1, B2, B3. Keep this as same as it is during elementary operations, because x, y, z are variables. They can vary the values, whereas constants, they are not variables. A11 is a constant, it's a coefficient. A12 is a numerical or a constant. A13 as it is during elementary operations. Now, in the second step, operate row and column elementary operations on both A and B only to see whether any row becomes completely zero. Then make it this way: Ax is equal to B is original set of equations. After elementary operations, it will be A dash x is equal to B dash. This is after elementary row and column operations. Here comes the most important step. To draw the conclusions. We have got the, after elementary operations, we have got in this form: Ax is equal to B transformed to A dash x is equal to B dash x. Now, x is not changing. X will be same in both the equations. Then you write EXB as A and B augmented matrix form, and you write A dash B dash in the augmented matrix form. This is transformed to this. Augmented matrix, you can refer to my previous lectures. Now, this is the final rank of A after elementary operations. When you consider this whole matrix, it is rank of augmented matrix K. Let us say this is K, augmented matrix. This rank of A, let us call it as R, and for the whole matrix A dash and B dash together, that we will call it as rank as R dash. Then, if A has all elements in a row are 0, but augmented matrix of A dash B dash may not be having all the elements in a row as 0. For example, please have a clarification on this. After row operations, let me say A has become A dash. B has become, because we are simultaneously operating row and column operations. Operating simultaneously on both A and B. X we are not operating on. B has become B dash. A dash, let us say it has become like this. 1, 3, 5, 4, 9, 7, 0, 0, 0. This is for A dash. And B dash has become 9, 3, 2. This is B dash. Now, for A dash, what is the rank? R of A is equal to 2, because one row is totally zeros. Hence, rank of A is equal to 0. That is transformed A. Then, what is the rank of this augmented matrix, total matrix? All the elements are non-zero, because it is a 3 by 4 matrix. 3 rows and 4. Augmented matrix is 3 by 4. This is augmented matrix. 3 rows. And none of the rows have all zeros, because this third row also in the augmented matrix there is a non-zero element. Hence, rank of augmented matrix is equal to 3. That means rank of A is not equal to rank of augmented matrix. Please try to understand this in this case. There can be three possible cases. We will discuss that. This is the most important step. Next, we will draw the conclusions. Conclusions. What can be the conclusions? After completing the row and elementary matrix operations, 1. First possibility is equal to if coefficient matrix rank is equal to augmented matrix rank. I will write in the brackets so that you will understand. Coefficient matrix is A11x plus A12y plus A13z. A11, A12, A13, these are all coefficient. Coefficient matrix rank is equal to augmented matrix rank. Please, if you want, you make a notes of it. Don't confuse yourself. Then it says that the equations are consistent. The equations are consistent and have unique solution. Consistent and unique solution. This is the first case. What is the second case can be? R is not equal to R dash. That means the rank of the coefficient matrix is not equal to rank of the augmented matrix. This says equations are inconsistent. Equations inconsistent and no solution. If and here for the third case we have to consider number of number of variables is equal to n, because it may not be 3 by 3 matrix, 3 variables, there can be 10 variables, 10 by 10 matrix. Number of variables are n. If R is equal to R dash and it is equal to number of variables in 3 by 3 matrix, rank is 3 and number of variables are also 3. Please understand this. Then they are consistent and unique solution. If rank is not equal to R dash, equations are inconsistent and there is no solution. If R is equal to R dash, but it is not equal to or we can say less than n number of variables. Ranks are same, but 3 variables are there. Only 2 equations are, rank is 2. Then what happens? It will have the equations are consistent but infinite solutions. But infinite solutions. Are you able to understand this? Very important. Conclusions, I will make a table. I will make a table. We will make a table like this. Rank of A coefficient matrix, that is A dash. With examples we will do. Rank of augmented matrix and behavior. With examples. Example. Let us say before the behavior we will have another column, number of variables, n. N is equal to number of variables. Are you able to follow this? Please follow. Very important. R is equal to, let us say, 2. After elementary operations, A dash is equal to a dash x is equal to b dash. X denotes the number of variables. This denotes number of variables. There can be 10 variables, 2 variables, 1 variable, no problem. After this, A has got, this denotes R. This whole denotes K. This is for R dash. Now, R dash is equal to, R is equal to 2. Rank of A. Let us take one by one some good example so that rank of A is, let us say, 3. And rank of R dash, augmented matrix, is 3. Number of variables is 3. Then what will be the behavior? Consistent and unique solution. This is very important table. Huh? If rank of R is equal to 3, let us say, rank of R dash is equal to 3. Let us make this way. Rank of R is equal to 2, rank of R dash is equal to 3, but variables are more. Number of variables are more. 2 equations, number of variables are more. Rank denotes the number of equations. In this is consistent because R dash and R is equal to same. The equations will be consistent, but not with unique solution, infinite solutions. Are you able to understand this? Then, the coefficient matrix has a rank of 3. The augmented matrix has a rank of 2. Then, irrespective of number of variables, let us say number of variables, it is not changing, it is 3. Then, the equations are inconsistent. Inconsistent and no solution. Here, R is less than, R is not equal to R dash. Then, if R is not equal to R dash, then equations are inconsistent and no solution. If R is equal to R dash, there are 2 situations will come. R is equal to R dash and number of variables is equal to R, then consistent and unique solution. If R is equal to R dash, but number of equations, number of variables is greater than rank, then consistent but infinite solutions. Please remember this table. Please follow the procedure I have explained and be confident in the examination. Do better in the examination. This type of questions are quite often in JEE Mains and JEE Advanced and in CBSE or other competitive examinations. Best of luck to everybody. Thank you for listening to me. If there is a value addition because of this video to you, your knowledge, please share my video and subscribe to my channel Maths and Science by IITian. Thank you. Best of luck. In the next class, we'll take a example on this. Numerical, we'll do it. And so that Any type of matrix problem that comes in the JEE Advanced or JEE Mains, you will be able to solve it if you see my previous videos and club them and understand them, and you apply them correctly in the examination. Best of luck. Thank you.